Bismillahirrahmanirrahim. Assalamu alaikum. First of all, I would like to thanks to the ICAZ 2020 organizing committee that for giving me an opportunity to discuss about my research work that is about the toxicological effects of titanium nanoparticles in Cyprinus carpio. MPhil Zoology from Department of Zoology, Wildlife and Fisheries in University of Agriculture, Faisalabad, Pakistan. Before the detailed discussion about my research work, I want to discuss about the importance of the aquaculture. I want to discuss what is aquaculture. Aquaculture is an extremely important subject. It offers fish rearing information and fisheries growth information. It widely used it widely used for the processing of fish with regard to growing demand of fish in the world day by day. The rising demand for seafood to meet future needs has also shown the significance of aquaculture. Water quality affects the growth and survival of fish as fish live in water. Therefore, regarding the growth of fish, water, temperature, pH, total hardness, and dissolved oxygen play an important role. Information about all these parameters is given by aquaculture. Fish are generally used to determine the health of the aquatic environment because toxins build up in the food chain and are responsible for the adverse effects on the health of the fish that cause their death in the aquatic ecosystem. But as we know that the ecological conditions are dynamic and anthropogenic activities has significantly increased discharge of toxicants into aquatic ecosystem. The heavy metal and pesticides, especially contamination of aquatic system has attracted the attention of researchers all over the world. Heavy metals have been recognized as serious pollution of the aquatic environment that cause serious impairments in metabolic, physiological, and structural system of both animals and plants. The accumulation of metals in the aquatic environment has direct impacts on the sustainability of the ecosystem. But public sewage system and manufacturing waste also cause pollution such that contaminants currently present on the earth and the atmosphere. The contaminants enter into the body organs of the fish such as gills, liver, kidney, and muscles by water nutrients. Then next we move about the nanoparticles. As we know that nanoparticles have vast range of diverse resources which consist of particular materials having size less than 100 nanometer. If we talk about the titanium nanoparticles, I prepared titanium nanoparticles by sol gel method. The manufactured nanoparticles were characterized by different methods such as X-ray diffraction, Fourier Transform Infrared Spectroscopy, scanning electron microscopy, and transmission electron microscopy. The important thing is to be noted that the individuality of nanoparticles was proved to be more poisonous as compared to their bulk forms. As we know that titanium nanoparticles consume in different forms, for example, common carbon-based toxins and microorganisms with tabloid industry, beautifying products, antibacterial and antiseptic configurations, and UV-resilient material. However, large number of nanoparticles mixed in the aquatic ecosystem and affect antagonistic properties of marine organisms. The existence of metal oxide nanoparticles in atmosphere is global problem due to its bioaccumulation in industrial pollutants, noxiousness, and manifested in customer foodstuffs. Titanium nanoparticles are immersed in aquatic atmosphere with adequate amounts as compared to world atmosphere. Sewage treatment plants are considered as the important pathway for the spread of titanium nanoparticles in water basin. Various researchers showed the chronic toxic important impacts of nanoparticles of titanium, which affect the marine organisms like catfish. Maximum range of titanium found in marine ecosystem is considered as 600 mg per liter for different fish species. Many researchers have described the histopathological and toxical properties of titanium nanoparticles in marine species, especially in fish organs. Here I want to discuss why I selected the common carp for my research work. The reason is that the common carp is economically significant fish and extensively found in aquatic ecosystem and shows about 10% of animal freshwater aquatic production in worldwide. To measure the quality of aquatic system, this fish can give interesting data. Various studies have suggested that carp can be used to measure the most damaging properties of toxins. These fish have great capacity of measuring toxicants as compared to the other fishes like zebrafish, Japanese Meteca. According to OECD standard, this is the appropriate fish models for ecotoxicological research. After that, when I selected, after that, when I have selected the fish that is the common carp, that is the common carp, I performed acute trial in the cemented tanks for 4 days, and I give and I have given the um, um, and I have given the dose about 100 to 400 milligram day by day, by increasing the dose day by day. And when all the fishes are to be died in after the 4 days trial, after that I checked the physico-chemical parameters on the daily basis according to according in toxicity trials. The mean 96-hour LC50 titanium nanoparticles for Cyprinus carpio was calculated as 168.58, while the lethal concentration was calculated as 289.249 respectively. These values will be given by the were given by a probit analysis method. After the trial was completed, I withdraw my species from the cemented tanks and dissect the fishes. After the dissection, I separate the fish organs that I need, which are gills, liver, kidney, and muscles. After that, I cleaned the organs with the help of the phosphate buffer of pH 6.5 and homogenized in cold buffer through blender. After that, the homogenized organs was centrifugated for 15 minutes at 10,000 rpm and 4 degree. After centrifugation process, the clean upper layer, which was called as a supernatant, was well maintained at -4 degree for enzyme assays, although the lower layer, which was called as residue, was wasted and then examined the LPO and GST activity with the spectrophotometer at 532 nanometer and 342 nanometer. The trial was done for enzyme assays, follow the various ways that are explained by Bugh 1978 and Manarvik 1969 respectively. After the determination of the toxicological effects of titanium nanoparticles in fish samples, probit analysis method used for the determination of LC50 value. For the statistical analysis of data, ANOVA and correlation method were used to check difference and interaction between different variables. After the completion of my research, I found that results during the experiment, the temperature, water, and total hardness are kept at stable level. After that, the mean percent mortality of the Cyprinus carpio against various concentration of titanium nanoparticles starting from 25 milligram per liter with gradual increase up to 210 milligram per liter was analyzed during acute toxicity trial. After that, fish showed significantly highest and lowest overall mean of LPO and GST activity simultaneously, which was noted after 96 and 24 hour of exposure periods respectively in table. Here I want to show the mortality rate of the fish Cyprinus carpi at different titanium nanoparticles concentration during 96-hour acute toxicity test. The final results that I concluded that Data concluded that the pattern of titanium nanoparticles for lipid per-oxidation activity at 96-hour concentration and lethal concentration was recorded in under as followed. Liver showed maximum liver show maximum disabilities as compared to gills, kidney, and muscles. When we talk about the pattern of the titanium nanoparticles for glutathione S-transferase activity at 96-hour concentration and lethal concentration was noted as followed. Liver show greater disability as compared to kidney and then gills and then muscles. Data collected was analyzed by comparison of means and analysis of variance. And thank you so much for your attention.